All right, screen is loading up there. Okay, so your first attempt here looks great. One of the things though you should notice is that there's still an x in both terms. Okay, which means you've either made a mistake or you didn't get the greatest common factor. Okay. Now you've done a nice job with the numbers. Okay, you first start with the numbers, and that's a 5. Very good. When you look at the variables, you want to find the one with the smallest exponent. So you do factor out an x, and then you do the same thing with the y here. You look for the smallest one. So everything is fine there. Now I'm just going to slightly rewrite this: 10x squared y plus 15xy squared. So the way I show this to students is exactly what you have here is you put that thing on the outside with an added little piece though, is I show division by each one. And that sometimes helps to clear up any potential problems. Look, the first one is 2x, that's for sure. But in the second one, maybe that's a times y. I don't know. It kind of looks like an x to me. It should be just 3y on the second one. The x's end up canceling.
Oh yeah, because it's just 1x, so 5xy times 3y equals 15.
Yes.
Xy squared. Okay.
Yeah. So that should be just the 3y there on that one. Number 2 looks fine. Number 3, there's just a tiny little, I guess. Nope, 3 looks good. Sorry, I'm just trying to zoom in here where I can see. 3 looks good. 4 looks good. So 15 you either stopped or ran out of time, or who knows what, right? Let's look at 15 here.
Okay.
All right, so you got the greatest common factor here between the first two, and so it is a 4k. So this becomes 4 minus 3k. Very good. And then you immediately write 4 minus 3k over here. So this is out of order though. That's maybe why you did it this way. Minus 3k plus 4. And then you figure out what goes in there. Now it's best to look at the constant. Like, how do you get to minus 20 from positive 4? And then you put that number down. You're like, okay, it's minus 5. And then you really, really hope that does minus 5 times minus 3k get you back to this, and it does. So that's really good. I actually call this like double factoring because you end up doing it again. You end up putting this 4 minus 3k here, and then the other one's 4k minus 5 there.
Yeah.
All right, so let me know when you get that down. We'll move to number 6.
Yep, I got it.
Got it. Okay. So I'd like you to talk me through this one. Tell me what to do first to factor this, please.
Okay, so the greatest common factor would be would this one not have a greatest common factor, or would you look at like the leading coefficient?
Yeah, you look at the 5 and the 10 first. What's common? What's the biggest number that goes into 5 and 10?
5.
Okay, very good. Now between x squared and x, which is the smaller exponent?
X.
So 5x. So you're basically dividing each of these by 5x. So tell me what goes in parentheses here, please.
It'd be 2.
Anything else?
Oh yeah, 2x.
So the 5's cancel here, but what about x squared over x? What does that become? That was from the last chapter.
To the power of 3.
So it's let me come out to the side here and show you. So it's 5x times x over 5x. So the 2 x's in the top make x squared. So here you can see what cancels here. The 5's go away, the x's go away, and you're left with just
1x.
Just an x, yeah. Okay. Now in the second one, it's 10x over 5x. Again, you can see that the x's cancel. 10 divided by 5 is 2.
Mm-hmm.
So that becomes
One
plus
plus two.
2. Now you
Mhm.
immediately write that over here on the right, and you hope that there's a number such that when you multiply in, you get back to the previous line. What do you multiply 2 by to get back to 2?
1.
1. That works here. That works for the other one as well. It's 1 times x. That's 1x.
Mm-hmm.
So then you factor out both of these x plus 2's from both terms.
Mm-hmm.
What goes in the other parenthesis?
5x plus 1.
You got it.
So when there's 4 like different terms in like this problem, would you just like put parentheses around or like break it up into 2 different parts to get the
Yes.
Okay.
Yes.
Okay.
And I really should give you another one to do, but if we're going to get through all of this,
Mhm.
we probably don't have time for that.
Okay.
But you may want to redo like 1 through 5
Mm-hmm.
in that scenario. Okay. Yeah, good question. That is exactly what we're doing. You look at the first 2 terms, you're grouping here. So let me know when you get that down. We'll move to 7. These are a little bit easier.
Okay. Yeah, I'm good.
All right. Actually, the next 4 are, so it switches types again. So we'll come back. We'll be able to do this type again. All right. So number 7, x squared plus 8x plus 15. So there's a bunch of different types of factoring. I call this type a equals 1. It's where there's a 1 in front of x squared.
Mm-hmm.
And your focus is on the 15. You're trying to find 2 numbers that multiply to 15. So let's write some of those down, like 1 and 15, those multiply to 15, 3 and 5, they multiply to 15. And we want them to add up to 8. Do any of these add up to 8?
The 3 and 5.
3 and 5. So here's what you write. You write x plus 3, x plus 5.
Mm-hmm.
Okay, you might think, okay, I've got it. Like why? This isn't hard. I can do this. Well, we'll look at another problem here. Look at number 8, and you'll see that you have to pay attention to the signs. The signs are very, very important here.
Mm-hmm.
All right, so for this one, you're looking for 2 numbers that multiply to minus 16. Minus 16 this time. So this is where it gets a little bit more challenging because I'm going to start writing them out here. Negative 1 and 16, 1 and negative 16. We don't know which one is positive or negative yet.
Mm-hmm.
Negative 2 and 8, 2 and negative 8, 4 and negative 4, negative 4 and 4. Do any of these add up to now negative 6? Notice it has to be this one here. This negative.
The 2 and negative 8.
Yeah, so it's this one here.
Mm-hmm.
So you write x plus 2, x minus 8.
Mm-hmm. Okay.
So the key here in both these problems is you look at the last number and you try to find 2 numbers that multiply to the last number, but add up to the middle one.
Okay. So is it always like when it's like 3, like a trinomial, will it always be like this? Like where you
When
have to
when
figure
there's
out.
when there's a 1 in front, yes.
Okay.
So notice 7, 8, 9, and 10 all have that form.
So if it's always like a x squared in the front, you have to do this type of like problem.
With a 1. It has to be with a
Okay.
1. Because you'll see
Okay.
like 11 is 5x squared, and it's
Mhm.
different than this.
Okay. Mm-hmm.
And identification is huge. I mean, to be able to identify them is key here.
Mm-hmm.
Okay, so let's take a look at 9. X squared plus 7x minus 18.
Mm-hmm.
So your focus has to immediately go to that minus 18. Okay, that means that 1 is positive, 1 is negative. So I'd like you to try to figure out which 2 numbers multiply to 18. One's positive, one's negative, but it has to add to positive 7.
Okay. Would it be negative 2 and positive 9?
Negative 2 and positive 9 works. This becomes x minus 2, x plus 9.
Okay.
So if you got that down, let's have you try 10 on your own here.
Okay.
Ask me any questions, of course. Same as the ones we just did.
Okay. Would it be 9 and -2?
So they have to multiply to 20. Multiply to 20.
Oh, okay.
That's key here. So two numbers that multiply to 20, the last number on the right.
Yeah, I don't know why I can't figure that out.
So did you write down 1 and 20?
Yes.
Did you write down 2 and 10?
Mm-hmm.
Did you write down 4 and 5?
Yeah.
Now these all add up to a positive number. Would you agree?
Yeah. So one
So
of them has to be negative.
they both have to be negative. That's how you get back to positive 20.
Okay.
So there's three possibilities, and we'll go back here just to the beginning. They're either both positive,
Mm-hmm.
one's negative, one's positive, or vice versa, or they're both negative.
Okay.
Okay, so your final answer here, what would I write for a final answer on the left?
X -4
Okay, anything
and
else?
X -5.
Good, very good. Okay. So kind of those problems all grouped together, and then 11 transitions to a new type of problem that you will see.
Okay.
Let me know when you're ready for that.
Yep.
Okay, so unlike the previous problems, instead of there being a 1 in front of x squared, there's a number that's not 1.
Mm-hmm.
It's a 5 in this case, okay? So this is kind of a grouping, factor by grouping problem,
Okay.
but it's also related to what we just did. So this time, you take the 5 and whatever numbers, whatever numbers in front, whatever's on the right, and you multiply them, and you get 30, okay?
Okay.
You get 30. So now you want two numbers that multiply to 30 but add up to 13.
Okay.
So we can do the list here: 1 and 30, 2 and 15, 3 and 10, 5 and 6. So the faster you can make this list, obviously the faster you can go. Excuse me, do any of these add up to 30?
Add up to 30.
I'm sorry, multiply to 30 but add to 13.
The 3 and 10.
3 and 10. So here's our options here. We can either write 3x plus 10x or 10x plus 3x. Like the order doesn't matter, and it's taking the place of this right here. So
Mm-hmm.
here's option 1: 5x squared plus 3x plus 6, 5x squared plus 10x plus 3x plus 6. Your next step is factor by grouping, okay? Just like we're doing in some of those earlier problems where you look at the first two terms. Would you rather look at 5x squared plus 10x or 5x squared plus 3x?
Probably the 5x squared plus 10x.
Yeah, so you have a choice, and you'll want to use the one that's better for
Mm-hmm.
you. So we did this earlier. What is the GCF This is a question for you. GCF between 5x squared plus 10x. What goes into both?
5x.
5x. Okay. And then what goes outside parentheses
X plus 2.
or inside parentheses? Good. Immediately write that over here, x plus 2. And then what goes in between them? What number goes in such that when you multiply in, you get
plus 3.
yes. Okay. Now tell me the next line here, please.
5x plus 3 in parentheses.
Good.
And then x plus 2 in parentheses.
Good. Order doesn't matter. If you wanted to go x plus 2 and then 5x plus 3, that's
Okay.
fine. So the key here is to recognize, what type this is. I'm telling you on the quiz, you wouldn't be told, so you would have to know how to do it.
Yeah.
You have to know now to multiply 2 and -4. 2 times -4, which is -8. You want two numbers that multiply to -8, but add up to 3. So here we go. -1 and 8, 1 and -8, -2 and 4, 2 and -4. Do any of these add up to 3?
No.
No. So this one is prime. Have you talked about prime?
No.
You have not.
Mm-mm.
Well, that's odd. Your instructor picked a problem that doesn't work here. So do you have the answer sheet to this?
No.
Okay. So this one's not factorable. I'm surprised they're giving you those, but that is possible. You might want to ask that in class tomorrow. Say like, hey, on the quiz, will we get one that's not factorable? Should we expect that?
Okay.
All right. Okay. Now let's look at 13. All right. So again, notice that the number in front of x squared is not a 1. It's a 6. What are we going? Which two numbers do we multiply here?
The 6x and the -6.
So just the numbers, 6 and -6.
Okay.
That's -36. This one does work. So I want you to find the two numbers that multiply to -36, but add up to -5x. It's got to be negative.
Okay. I got 4 and -9.
Yes, 4 and -9. So we have a choice here, 6x squared plus 4x minus 9x minus 6, or we can switch the order. They actually both work. You just, maybe there's one that stands out to you that you like better. Which one do you like, line 1 or
Probably line 1.
Line 1. All right, so we'll get rid of line 2. Gone. All right, now look at the first two terms. What is the GCF between them?
2x.
So 2x, and then in parentheses,
It'd
okay,
be 3x
anything else?
plus 2.
Good. And then you immediately write that off to the side here. Figure out what goes in that next position.
-3. And then it'd be 2x minus 3 in parentheses.
Okay.
And then 3x plus 2.
All right, very good.
So on problem 8, can you don't have to do it again, but can you like remind me like what you do? Like I know how this one on like where it's like a number in front of the x, you have to multiply the first by the last. What do you do on when it's like an x squared again?
So you actually are doing exactly the same thing. It's just like you said, it's a 1. 1 times -16 is -16. But now it's got to add to -6.
Okay. Okay.
So it's kind of the same. Like you know, but it's always the last number because of the one there.
Okay.
Okay, now, you know, and interestingly enough, 14 is kind of like 8, so we'll look at that next.
Mhm.
Kind of worked out nicely. So yeah, you could think of it, okay, I'm going to multiply 1 times 48, but 48 is
Mhm.
it's already 48. So you just start writing them out here. I don't remember if you're allowed to calculator or not.
Yeah.
You know, that would be something to consider here. 6 and 8 here. Now, the question is also like, well, when to stop?
Mhm.
Well, like 7 doesn't work. Do you agree? 7 doesn't go into 48. See how I wrap around to 8?
Mhm.
Whenever you wrap around, you're done. That is kind of one way to answer. It's not the complete answer, but
Mhm.
it's kind of the answer.
Okay.
Now these are both positive.
Mhm.
What do we want it to add up to?
Negative.
Negative. So how do I get a positive 48 from a negative number?
2 negatives.
2 negatives exactly. Do any of these add up to negative 14?
Um. Yeah, the -6 and -8.
Good.
I think the only thing that's like confusing is like how they all like almost look alike, but like there's so many different rules for each one.
Yes. Yes. So there's there, let me do this now since you asked about it. There are basically 5 different types here. The first is GCF. Okay.
Mhm.
Greatest common factor. The second is what's called difference of squares, which we have not seen yet. It's number 16.
Mhm.
The third one is what's called a perfect square trinomial. I have not seen that yet on your sheet, but it's probably
Mhm.
coming. 4 is a equals 1, and 5 is a not equal to 1 or grouping. So there are 5 types that you need to um, you have to identify, and
Mhm.
maybe if we got any time at the end, we'll try and do that.
Mhm.
So you actually look in this order. You actually, you know, when you played basketball, you need to identify, you know, the defenses, who's guarding you, things like
Mhm.
that. You know, look for mismatches. It's kind of the same thing here. You're looking like, is there a greatest common factor? You should always look for a greatest common factor. And
Mhm.
from there, you know, maybe you're done, maybe there's more to do.
Mhm.
All right, so this problem here does have a greatest common factor. There is a number or a letter that goes into all 3 of these. What is that?
Um, it'd be 3.
3 goes 3
Wait.
does, yeah, that is it. That's right.
Okay, yeah.
So it's 8y squared plus 6y minus 5. Very good. So now it's like, all right, there's no more greatest common factor, but maybe there's something else you can do. Like maybe you can do um, an a not equal to 1, like we've been doing. Maybe you can take that 8 and multiply it by the minus 5. Okay.
Mhm.
So you're looking for 2 numbers that multiply to minus 40, but add up to 6. Again,
Okay.
there's no way to know until you do this. You want to be very, you know, careful and complete about this list. Let's see here, -5 and 8, 5 and -8. Do any of these add up to 6, positive 6?
Um, the -4 and 10.
Yeah, so this is 8y squared. And remember we have a choice here, minus 4y plus 10y minus 5, or we can switch the order.
Mhm.
All right, so now this is a grouping problem. So why don't you try it from here?
Mhm. Okay.
And don't worry about the 3. Just keep going from this step.
Okay. I got 4y plus 5 and then 2y minus 1.
All right, now let me just quickly FOIL this and see if that works out. 8y squared, that works, minus 5. And then we've got minus 4y. That does it. Okay, very good. And then last thing is to bring the 3 down.
Yeah.
All right, any questions on that one before we move to another?
No.
We're gonna do 18 next. We'll come back to do the other two, but it's more like 15.
Okay.
Again, like you always look for GCF first.
Mm-hmm.
You know, is there a GCF? In this problem, is there a number that goes into all three?
2.
2. So this becomes x squared plus 13x plus 40.
So whenever you're doing a GCF off of like this, would you always multiply like the first like x squared times 40 and then do like the figuring it out, right?
I mean, you could do the 1 times 40. You really could. But it is, because it's 1 in front, you automatically know it's the 40 that you're splitting apart.
So whenever you're doing GCF, it'll always look like this.
No, GCF was just the first part
Okay.
where you take the 2 out. That's the GCF.
Okay.
So 2 numbers that multiply to 40 but add up to 13.
I got 5 and 8.
5 and 8. So it becomes x plus 5, x plus 8 with the 2.
Yep.
Let me know when you're ready. We're going to go to 17 next.
Yep, I'm ready.
Okay, fantastic. Okay, so the very first type of factoring you always do is a GCF. And I keep repeating myself because I really want you to like hear those words when you're going to your test or quiz, GCF first, GCF first. So look at 40, 24, and negative 72. What is the largest number that goes into all three of those?
Would it be?
And it
Is
maybe
it
start with
12?
this. Maybe start with the smaller one, 24. Yeah, it's like numbers that go into 12 into 24. 12 does, and it goes into 72, but 12 does not go into 40. So it could be bigger, could be smaller. What are all the numbers that go into 24? Try to find one that.
2, 4, 6. Is it
Hang on.
8?
Eight's looking pretty good.
Mm-hmm.
Okay, so 8 for sure. Now, next thing you do is you look at the x to the 6th, x squared, and x squared, and you find the smallest exponent.
So x squared.
Okay, so x squared. And then y squared, y to the 8th, y to the 10th,
Y squared.
y squared, yeah. So you're dividing each of these by,
Mm-hmm. So the first one, would it be parentheses 5x to the 4th?
yep, very good. Keep going.
Plus 3 and then y to the 6th.
Okay. Minus,
Minus 9 x squared, y squared, so it would be y to the 8th.
very good.
And then so this one, now would you multiply 5 times -9?
Yeah, I mean, so that's where it's like you've done so many in a row, and you're like, oh, I know what to do. 5 times 9, but this one is prime at this point. And how would you know? I'm not sure to tell you at this point. It's really messy. Like it doesn't look like any of the ones that we've done.
Mm-hmm.
So this one is done. This is as far as you can go.
Okay. But let's say like if it weren't to be prime, would that be the next step?
If it were not like if it were, yeah, I mean yes, that would be the next step. But this one's really not in the right form at all.
Mm-hmm.
It's just
Okay.
very, very off.
Mm-hmm.
And I know that's a question students have. It's like, well, how do I know when I'm done? And I don't have a good answer for you at this point because it's like you just it's like you go through the checkbox. You're like, all right, did I do
Mm-hmm.
that? Did I do that? Is there any more of these?
Mm-hmm.
And I know that's not a great answer, but that is the case here. Okay, so number 16. 16 is a difference of squares.
Okay.
So we'll look at that here. How do I know that? It's got two terms.
Mm-hmm.
That's one of the giveaways. You were asking me earlier if it like 4 terms, is it a grouping problem? Yeah, it is. 2
Mm-hmm.
terms is almost always difference of squares.
Okay.
Okay. Now the form you want to write this is what's squared, something squared minus something squared, and you're trying to think of like what goes in parentheses. So what goes in parentheses so that when you square it, you get back to the previous line. So like the case of
Mm-hmm.
64, that's 8. 8 squared is 64.
Mm-hmm.
The case of y squared, well, that's y.
Bye. Mm-hmm.
So then your teacher at some point would have put this down on the board, a squared minus b squared. So in your problem, a is y, b is 8. A is y, b is 8. Okay.
Mm-hmm.
And so that's a minus b, a plus b. So in what you're doing is you're just replacing a and b with y and 8. So instead of a, it's y. Instead of b, it's 8.
Mm-hmm.
Instead of a, it's y. Instead of b, it's 8.
Mm-hmm. Okay.
So we should do at least one more of this.
Mm-hmm.
Have you seen this formula before?
Um, I think we've gone over it. Yeah.
Okay. All right. So let's try another one here. Let's say it's x squared minus 9. Okay.
Okay.
Tell me what goes in parentheses here, please.
Okay. So it'd be x and or wait, wouldn't just the first one be x and the second be 3?
Okay. What goes in between?
Oh yeah, the plus and
So
then
one's
the minus.
positive. Yes. Very good. How about x squared minus I don't know. Let's go 36. What goes in parentheses here?
So it'd be x plus 6 and x minus 6.
All right. Very good. Okay. So we're going to move on to 19.
Okay.
19, 20, 21. The rest here are they're all solving. Okay.
Mm-hmm.
And solving is not too bad, at least in this first form. So you set each term equal to 0. And what does Matthew mean by each term? If it's got an x in it. So but the parentheses kind of create a term. Like this is a term that's circled in red. This is a term circled in red. Okay, it's got
Mm-hmm.
an x in it. So it's 3x minus 2 equals 0. 4x plus 7 equals 0.
And then it's just getting
Just
the
solve. Yeah.
x
So
by itself.
could you try solving those for us, please?
Yeah. So I got x equals 2/3
Good.
and x equals -1 3/4.
Yeah, or -7/4. You do not have to convert that to a mixed number. You can leave it improper like that.
Yeah, I don't. Our teacher, I don't know why, but he wants us to convert it to a
Really?
mixed number. Yeah.
Wow. Okay. Does he use a sundial to tell time? I mean, that's a weird that's
Yeah,
weird.
yeah,
It's a but as a math student, it's like, well, wait, which is, and it's always what the teacher wants. So continue to do what
yeah,
he or she wants, and that
mhm,
applies to all classes.
yeah.
All right, number 20 here. So again, because this is actually already in factored form, which is why we're able to do this. We're going to have to actually start factoring some of these, but
Mhm,
you set each term, okay, and a term has a variable in it. So think of this as 4m. It's really like almost like 4m is in parentheses times m plus 6. They're
mhm.
they're each they're each terms. So you're going to set 4m equal to 0 and m plus 6 equal to 0.
Okay.
You never set a number equal to 0. It's got to have a variable in it.
hmm So would it be 4m equals 0 and m equals -6?
The one on the left, you can divide both sides by 4. You have to get m equal to or just m.
Oh, okay.
So what is 0 divided by 4?
Um, would just be 4.
So think of division as a sharing problem. You have nothing to share, and 4 friends are coming over to eat. What are they going to get? They're going to get
0.
nothing. Yeah.
Okay.
And the other one is correct, -6.
So these are always a negative and a positive, right?
Not always. No. That's a
Okay.
bad generalization.
Mm.
Any uh any other thoughts or comments on that before we move on?
No.
Okay. So starting at 21, you have to factor to solve. Yeah, it really should say solve by factoring. It just says to solve here. So you have to go back to your list. Number one type of factoring is a GCF.
hmm
Okay? So I ask you to look at these two terms here. What is the GCF between those two terms?
2k.
So we got 3k minus 5 equals 0. So now what do you set equal to 0? What at this point?
What equals 0?
Yeah, just like we did in the last problem. See how it was already factored in the previous problems?
hmm
What are we going to set equal to 0 here?
Um, the 2k.
Very good. So you can almost think of it as in parentheses 2k equals 0. What
hmm
else? What else are you going to set equal to 0?
The 3k minus 5.
Very good. Could you solve these for us, please?
Yeah. So I got k equals 0 and k equals 1 2/3.
Yes, that's correct. All right, very good. Now, one thing I want you to notice here about the last few problems we've done, 19, 20, and 21. Do you see how they're equal to 0, equal to 0, and equal to 0?
Yeah.
So you get to a problem like 22, and it's like, wait, it's different. It's different. It's
hmm
not equal to 0. It equals 4t. It's like, well, what do I
hmm
do? You always make the problem look like one that you know how to do. You subtract 4t from both sides of the equation. So it's now t squared minus 4t equal to 0.
Mm-hmm.
So you have to have 0 on one side of the equation,
Okay.
right? Now, our options for factoring, you always start with GCF. Is there a GCF here?
No.
Is there a letter that is in both?
Oh yeah, T.
Yes, so you could factor out a t from both of them.
Okay.
Tell me what, when you get it down, what goes in parentheses?
T minus 4
Good.
equals 0.
All right. And nice thing here is that you can set each of these equal to 0. And once you do that, one of them is already solved. You literally
Mhm.
set this t equal to 0. Well, that's one of your solutions. Then you set
Mhm.
the other one equal to 0. Same thing. So t equals 0 and t equals
4.
Yeah. Awesome. Let me know when you're ready, and
Mm-hmm.
the next one here. So x squared plus 11x plus 28 equals 0. Notice it's already set equal to 0, so you don't have to move anything around. But now you looked at problems earlier where if it was just the part in the square here, you were saying, well, do I take the 1 and multiply it by the 28? Yeah, that's exactly what you do.
Mm-hmm.
Okay, so you're going to take 28, find two numbers that multiply to 28 but add to positive 11.
Okay. I got 4 and 7.
Okay, so you write x plus 4, x plus 7 equals 0. What is the next thing to do here?
Would it be to get the x's by themselves? Or to get it to equal to 0? So x plus
Yes.
4 equals 0 and x plus 7.
Yes. Yeah, very good. That's exactly it.
So I got x equals negative 4 and x equals negative 7.
Yes. All right, just because we're really short on time here, I'm going to 24 is just like 23, so we're gonna skip
Mm-hmm.
that and we'll look at
I think
25.
26 is like the most different one. It equals negative 5.
Yeah, we'll get to that one here.
Mhm.
Let's do 25 first. We should be able to get both of them in.
Okay.
So this is it's Matthew's really helping you here. Like I'm telling you what it is, that's where
Mhm.
you're gonna need to get more comfortable. You have to multiply the 4 and the 15, which is 60.
Mhm.
So you want two numbers that multiply to 60 but add up to 23r. In this case, it's 3 and 20.
Mhm.
So it's 4r squared plus 20r plus 3r plus 15 equals 0. And then you find your GCF between 4r squared and 20r, which is 4r, r plus 5, r plus 5 over here. And then in the space in between, it's plus 3. So
Mhm.
4r plus 3, r plus 5 equals 0. And
then
you
you
set
get them
each.
both equal 0.
Yes.
Okay.
Let me know when you're ready for us to do 26.
Yep.
Okay, so 26 you mentioned before, you're like, there's a minus 5x on the right side of the equation. We've said a couple times now, you have to get 0. So you're going to add 5x to both sides. You're going to undo it, move it to the other side. 6x squared plus 5x minus 6 equals 0. This is that form where you have to multiply that first number and that last number. Okay, and now you want two numbers that multiply to negative 36, but add to 5. So that's going to be 4 and 9, or one's negative, one's positive. So it's going to be 6x squared plus 9x minus 4x minus 6 equals 0. You look at the first two, factor out a GCF of 3x, 2x plus 3, 2x plus 3, ends up being minus 2 in here. So your answer is 3x minus 2 times 2x plus 3 equals 0.
Okay.
Okay, and you set each of those equal to 0. And you get 2/3. And then the way you guys are doing it, minus 1 and 1/2 over here on the right.
Okay.
All right, so 24 is just like 23. So you want to give that a try on your own. Probably only take you 1 minute. Maybe do that now rather than waiting. Let me just stop the recording here.